Some of you may be aware that Lake Ohinewai is one of the trial lakes that we've been looking at to try to remove as many pest fish as possible and look at potential ecological changes in that lake. So in 2011 there was a major pest fish removal attempted. There was also installation of a one-way barrier to try and prevent reinvasion by koi carp back into the lake. And there's been a little bit of follow-up work that's gone on from there to look at what the fish population has done post that pest fish removal and also any potential changes in water quality in that lake. So in terms of my co-authors here, Adam Daniel actually did all of the initial pest fish removal and most of the work on this early on. Grant Tempero has followed that up with other fish studies, and I've really done bugger all for this project. So any really tricky questions, I'll defer you to my co-authors for that. So unfortunately, I've missed most of the talks today because I've been teaching a course. So some of this may have been followed through before, but basically, obviously, the Waikato River Scoping Study identified that the Waikato shallow lakes are mostly substantially degraded and that there are a large number of driving forces for that degradation of the lakes, including things like diffuse inputs of nutrients, sediments, internal regeneration of sediments. But pest fish are seen as one of the driving influences causing declines in water quality in these shallow lakes within the Waikato region. And at least 8 of the 18 most nutrient-enriched hypertrophic lakes in New Zealand are those of the shallow Waikato lakes in the floodplain. So the Waikato Tainui Raupatu settlement claim, of course, has restored guardianship of the river and floodplain lakes to co-governance between Tainui and local government, and there's a lot of money involved in clean-up, and there is a series of targeted restoration goals for the Waikato lakes that includes things like expansion or restoration of the tuna fishery, but also trying to improve lake aesthetics, trying to improve lake water quality, and controlling or eliminating pest fish within these lakes is a specified restoration option to try and achieve some of this recovery of these ecosystems. So the Waikato Raupatu River Trust has an environmental plan, and part of that environmental plan is policies related to control of things like non-Indigenous species, so promoting things like eradication tools and directing research effort towards determining effective methods for controlling, managing or eradicating pest, plant and animal species. So sorry, a whole lot of slides there with a whole lot of writing on. Didn't expect you to read all of that, but just kind of pointing out these major issues. So the Waikato River Scoping Study also recommended, in terms of if we want to try and rehabilitate some of these shallow lakes, we need to try and remove pest fish if they are a driving factor. It's very unlikely in any system that you can completely eliminate pest fish from that water body unless you resort to fairly drastic measures like rotenone poisoning. And even rotenone poisoning may not be effective for the most resistant species. Some pest fish species like goldfish are notoriously difficult to remove even with rotenone. Their sensitivity to rotenone is basically above the maximum solubility of rotenone in water. And so you might knock the population down a bit for goldfish, but you're probably not going to completely eradicate them. So you need to therefore try and resort to a number of other techniques to try and remove pest fish. So things like netting, electrofishing, potentially encouraging a commercial market for things like koi carp. So the Waikato River Scoping Study recommended that fish biomass be reduced by 75% in order to try and reduce the ecological impacts of these things within these lakes, or to a threshold level of less than 150 kilograms per hectare. Because that sort of level has been determined by some studies overseas as being the sort of threshold level where you start to see significant ecological effects of things like common carp. But in fact, ecological threshold levels vary from study to study. So some reviews recently have recommended 400 kilograms per hectare as an ecological threshold for common carp, whereas some studies in North America have recommended threshold levels as low as 50 kilograms per hectare. So there's a huge range of established ecological threshold levels. But because we have a large number of diadromous fish species that migrate within our fish fauna, we also need to, whatever technique we use to eradicate fish or to prevent them from re-invading a water body, we need to try and provide for differential fish passage too, so that adult eels, for instance, can actually get out of the catchment to go to sea to spawn, and that things like whitebait and elvers can actually get back into the lake. So as part of our OBI research work, Lake Ohinewai was recommended as a test model lake to try and undergo a pest fish removal and to then look at what the ecological impacts of that might be through time. In terms of the fish fauna that we have in the Waikato floodplain lakes, obviously there's a vast number of them, many of which are exotic. So common carp is obviously the most important one. Then we have goldfish, bullhead, catfish, rudd, perch, gambusia, rainbow and brown trout. And then of course we have a suite of native species as well. And in many parts of the Waikato catchment, these guys greatly outnumber the natives, both in terms of number of adults, but particularly in terms of biomass. So things like the lower Waikato River, about 75% of the fish biomass is common carp, also called koi. So koi were introduced in the late 60s, probably not telling you anything you don't already know, and particularly abundant in the Waikato River system below the hydro dams. And as I said before, constitutes up to about 75% of fish biomass in the lower river and in these shallow floodplain lakes. So Lake Ohinewai, relatively small lake, just 16.5 hectares, very shallow, situated here, quite close to the main stem of the river, but not actually connected to it. So Lake Ohinewai deteriorated from a relatively stable, relatively clean lake in the late 1980s, early 1990s, to a stable eutrophic algal-dominated system. So large macrophyte beds that were there in the mid-80s just suddenly collapsed and the system turned over to an algal-dominated system. And Lake Ohinewai discharges via a single outlet into the Lake Waikari system. So it discharges from Lake Ohinewai into Lake Rudd and then out into Lake Waikari. So the fact that it only has a single outlet means that it's quite a nice system to look at, because there's potential to install something like a fish barrier there to prevent reinvasion by carp if we can get them out. And it's quite a small lake. So this is the lake here, right, and this is the outlet drain, and it very conveniently passes under Rotokawa Road there, and there's a culvert that passes through there. Adam might have already told you about this culvert and the fish trap earlier in the day. So one of the options here to try and maintain the carp out of the lake once we had removed them was to try and install some sort of barrier at this lake outlet. So the Lake Ohinewai removal phases, there was a mass removal that occurred early in 2011, and we basically threw everything we could think of at it in terms of all the equipment that we had. So we tried boat electric fishing, we had baited pen traps, we tried bow fishing, we tried very, very large seine nets, and in addition to all of that removal effort, with fight netting as well, in addition to all that removal effort, we also installed this one-way barrier in the middle of 2011 to try and prevent carp from reinvading back into the lake. And then the following summer we followed up with a second fish removal and tagging in order to determine the biomass population size in the lake. And there's been ongoing monitoring of the lake since, and there's a lake model that's been produced as well. So in terms of the highlights of the removal, we removed around about, it was established from tagging fish and then recapturing them that the initial biomass of koi carp in the lake was about 245 kilograms per hectare, so well above that 150 kilogram per hectare threshold, and we wanted to try and drive that down as low as we could. Okay, So things like baited traps work really well. Boat electric fishing works really well, but only for some species. Brendan probably told you about that. Using a big seine net, which is one of the techniques that they use in Australia for removing very large quantities of carp from water bodies, actually didn't work at all well in here because there's a lot of snags. So unless you've got really very, very large machinery that can simply drag the snags as well as the fish out of the lake in a seine net, it's not going to work. And of course, snags are important habitat for fish anyway, so you don't want to completely strip the lake of any kind of large woody debris by doing seine netting. So some of the type of netting techniques we use, like this mega fyke, pretty successful, really good at removing carp, but some of these things in a small lake where you have difficult access can be really difficult to try and set and also to retrieve if you're working out of small boats. So you've got to kind of target your removal method to the realities of working in some of these kind of conditions. Pen trap, again, a very large kind of system, worked pretty well, needs a large space. Carp can dig under it, so even if you put the wings on the bottom and kind of peg them out across the bottom, the carp can dig underneath them and so on. So carp are pretty resourceful kind of species. This was the pen trap, the pod trap that Adam developed, again, worked really well. Has a feeder system to attract fish in. These are fairly small though. And one of the issues about all of these things is that it's all active fishing, right? And the problem with active fishing is the cost of personnel. So if you have an initial fish biomass and you're trying to drive that fish biomass down, to catch the first 10 kilos of fish per hectare actually doesn't require a hell of a lot of effort, but as the biomass decreases, the amount of effort that you have to put in to get some more fish starts to increase exponentially. And it gets to a kind of a crossover point where the cost of trying to remove more fish actually outweighs any benefit that you might derive by getting rid of those fish. But if you can combine that with some kind of passive removal effort, like a trap that therefore keeps the adult carp from reinvading back into the lake, you can actually substantially reduce your overall fishing costs in that way and make the whole thing more economical. So this was the barrier. I think Adam's already talked to you about this, so I won't go into all of the detail about it. Pretty simple, pretty cheap to construct, very convenient that we just had this one outlet, one culvert that it would fit very nicely into. It's got these swing bars on it. So not only does it prevent the adult fish from getting back into the lake, but it actually allows adult fish to leave the lake if they choose to do so. So adult koi carp have this pushing behaviour. These fingers here are just weighted, so adult fish can actually push through these and actually exit from the lake when they're going down into somewhere like the Whangarino to find spawning territory, but then when they try to return to the lake, they can't get back through. Whereas, eels can exit the lake also to migrate to spawn. Things like elvers and galaxis can come back in. The problem with this design, of course, is that it doesn't prevent small koi carp and small other pest fish from getting back into the lake. And the system was designed to be able to be easily cleaned, although there hasn't actually been a lot of maintenance required on this to keep it clean. It's pretty nice design. So this was the data then for common carp. So we had an initial biomass of around about 240 kilograms per hectare, and all of the work that went on over the few months early in 2011 to try and remove these fish resulted in a very substantial reduction in biomass, down to below just under 100 kilograms per hectare. But the cost of that was about $40,000. So for a 17 hectare lake, to reduce carp biomass by 100 kilograms per hectare was around $40,000 worth of work. At this point we had installation of the barrier, which cost about $5,000, and what we saw is that in November, when we went back to the site, we actually got a reasonably substantial further decrease in biomass, presumably because adult carp during winter had left the lake and couldn't get back in. So the manpower cost of trying to fish the lake from here to here would have been very substantial if we just kept on fishing, because we got a low biomass, and yet this trap was pretty effective at at reducing biomass further. And you see the further mass removal effort that we undertook here with electric fishing and fyke nets and cod traps and all the rest of it, actually, because there was a relatively low biomass in the lake, all of that effort actually didn't result in very much further reduction in fish, because there's so few fish left in the lake, they're quite hard to catch. So this is kind of proof of the pudding, really. Here's about 60 koi carp milling around this trap, all trying to get in at the point when they're all migrating, trying to get to spawning habitat. What about other pest fish species? Goldfish in the lake. Goldfish were at relatively low levels in the lake, only about tenfold less in terms of biomass compared to koi carp, and there was a substantial reduction with the initial removal, but the barrier didn't really have any effect on goldfish numbers in the lake. Okay, so goldfish are not primarily, don't seem to be a migratory species that are leaving and then can't get back in, and the adults may in fact be small enough to get through the gate anyway. With respect to bullhead catfish, similar sort of thing. Either non-migratory or they're just simply able to get back through the barrier. So this then is the overall view of the pest fish population in that lake, very much dominated by common carp, as is most of the other systems within the lower Waikato. There's been some follow-up fishing that's been done following on from this. Rather than tagging fish and releasing them and then catching them again, which is kind of double handling and therefore twice the expense, the follow-up fishing that's been done is just simply looking at catch per unit effort. And what we can see is for carp, there's this very substantial reduction that occurred with the initial effort, and then there's been some recovery over 2 years, but to nowhere near the original level. So there seems to be quite a nice ongoing effort by the trap in order to keep pest fish or keep carp population low, but you see there's been quite good recovery of goldfish after the initial removal, so obviously having no effect on goldfish. 2013, looking at the size distribution of carp in the lake, you might expect that if you're excluding all the adults there might be some shift in the size distribution of carp in the lake, but in fact it's exactly the same size distribution as prior to the mass removal. And this is something that we need to follow up on with the further work that's going to go on end of this year. Take-home message: hasn't made any effect on water quality in the lake, and early signs are that there may in fact be some water quality improvement. So this box here is the time when the removal occurred, the mass removal. For a long period of time, the water quality measured as Secchi disc was pretty well constant at pretty well rubbish. You can see about that far into the water, right? And the latest sample will show a great improvement to a metre or so in terms of Secchi depth. So there seems to be a recovery in water quality, and early work also showed potentially a decline in suspended solids in the lake as well. So there are good promising signs that water quality in the lake might be improving, so long as this carp population can be maintained at a low level. And one of the things that we're planning on doing is later this year, in November, we're going back and we're going to do another big tagging and removal effort to try and get a really good handle on what the biomass of fish in the lake is at the end of this year, so we can compare to earlier times and see whether or not we are getting this really prolonged effect of the trap in maintaining a low carp density within the lake.